Hello and welcome to the first episode of Canadian Crop Genepool. This will be a three-part series on the genetic diversity of various crops in Canada. In this case, small grain crops like barley, oats, and wheat. For our first episode, we'll be covering barley. Let's get started. Barley is one of the oldest cultivated crops in the world. Today it constitutes the fourth most cultivated cereal worldwide, with the top three being corn, rice, and wheat. As per usual, through the plant breeding process and the various changes in methodology over time, the gene pool of barley has become shallower and shallower. This is a product of continuous breeding with only elite cultivars. Currently, it's estimated that among the elite cultivars, the total gene pool is less than half of what's found in wild barley lines, and is genetically homogeneous or closely related lines across vast areas, or more akin to a gene puddle than a gene pool. This pretty much guarantees that if a large-scale epidemic of a disease or crop failure due to a new strange environmental effect would wipe out a good chunk of our crops. As such, various individuals have been tinkering around with trying to increase the gene pool size to allow for more variation both in disease resistance and tolerance of abiotic stresses like drought, flood, and so on and so forth. The use of genetic markers has been used as a good estimation of genetic diversity, as well as a way of measuring and tracing the lineages of the different cultivars we have in modern times, as well as how many genes from each parental cultivar or line can be found in current cultivars in modern times, whether in a large group or specific individual genotype. The researcher, Dr. Mebarak Lamara and company, used two types of genetic markers, SSR and DART, to compare the genetic pedigree to the stated pedigree, and used both to assess the total amount of genetic diversity in Canadian barley, make it suitable and very accurate. A large number of cultivars were assessed, 92 in fact, and here are the results. The result of this paper found that the 6-row were the least genetically diverse populations, with the 2-row barley cultivars being much more genetically diverse. It was also found that the pedigree values were far lower in terms of genetic diversity than was previously expected, indicating that indeed the records are incorrect in terms of parents were used to breed these modern cultivars. With SSRs, it was found that the average genetic diversity of the entire 92 cultivar population was around 0.15, or 15% of the total genetic diversity found within the total population of wheat. 0.04 for DART markers. The lowest genetic distance was found to be 0.002. This would be the genetic distance between Galt and Melvin, which were nearly genetically identical. The lower value for the DART stems from the fact that fewer markers can be utilized for the system in comparison to SSRs. Pedigree analysis also excludes other factors that should be factored in, such as how closely related are the parents. Many of the old cultivars had multiple names. How much selection pressure was placed on the resulting seedlings. But from what can be concluded, the larger gene pool is found in the 2-row barley in comparison to the 6-row barley. So the mingling of 2-row barley with 6-row barley to breed more genetically diverse populations of 6-row barley would be desirable for future improvements in barley breeding. That about covers everything. Thank you for watching. Thank you for watching this video. If you enjoyed this video, please like and subscribe. If you really enjoyed it and think you can donate, you can do so at Buy Me a Coffee, link in the description below. Thank you for watching.